Okay, so we're going to continue, and like I said, we're going to look at two additional examples for the trig equations. All right, so our first one is looking at the places where sine 3 theta is equal to -1. All right, so remember, like we said on the last example in the last presentation, that what we're really watching for on these problems would be a situation where there is something other than a theta in the parentheses. Okay, so remember that I'm looking at this and I'm saying to myself, okay, so this is not just theta, so I know then that the problem is going to require me to do a little bit more work than the ones that we did earlier in the week. Okay, so the first step is to look at the places where sine is equal to -1. And so for this, we ignore the 3 in the parentheses and we treat it just like it was sine theta is equal to -1. Now, I know that as far as my memorized values go, I don't have one for a 1 or for a -1 because I know that sine pi over 6 is 1/2, sine pi over 4 is square root of 2 over 2, and sine pi over 3 is square root of 3 over 2. So I know that I don't have a value in my head memorized for -1. So that's going to need to come from the graph. All right, so remember that we're limited on our interval from 0 to 2 pi, so I have our typical sine graph right here on the screen, and we want to look for a place on the graph where sine is equal to -1. All right, so that's happening here at this point. All right, this is where we're at -1, and the angle that that's happening at is 3 pi over 2. And note that that is the only place on the sine graph, if we're looking at the graph between 0 and 2 pi, where that happens. All right, so the next step, remember, is to add some rotations to that. So we talked about this in the last example. So essentially what we want to do is we want to think about 3 pi over 2. Okay, and we want to think about that being like an angle. So that angle would sit straight down. So this is 3 pi over 2. And what I now want to do is look at taking an angle that would rotate completely around. So that's a 2 pi. And then go back to 3 pi over 2. So that would be a 2 pi plus a 3 pi over 2. All right, now remember that you need a common denominator in order to add these things together. So instead of 2 pi, I'm going to write this as something over 2. So I'm asking myself what number divided by 2 is equal to 2? And that would be 4. So 4 over 2, that's the same thing as this 2. And now I can add them together. 4 and 3 make 7 pi over 2. And so that will be my next expression for sine equaling -1. That would be the next one. And remember we said we typically do 3. We may need more, but 3 is a good place to start. All right. Note your pattern. So how did you get from 3 to 7? All right, so how do we get from this one, from this 3 to this 7? We added 4, so I'm going to do it again. So 7 plus 4 is 11 pi over 2, and that will be the next one. And then I'm going to ... I'm going to come back and add more if I need to, but for right now, I think that's enough. Okay, so that takes care of step 1. That is getting the answers for sine equaling -1. So now the second step is to bring back in the actual problem. So the real problem was sine 3 theta equaling -1. And remember that our goal here is to somehow take this 3 theta and make it equal to the first one of our answers here. So I'm going to come down here and see how that would happen. So 3 theta equals 3 pi over 2. Now let's solve it for theta. So remember, if I'm trying to get theta by itself, I can divide by 3, or I can multiply by 1/3. Same thing. I tend to do the multiplication because it's just a little bit easier to work with. So that's going to give me theta equaling 3 pi. 3 times 2 is 6. All right, and that's going to reduce, so that's going to reduce to pi over 2. All right, so in terms of answers to my problem, final answers, pi over 2 is the first one. All right, so let's look at our next one. Now, remember that what we said to do is to note what's happening with your pattern. So the next time through, I'm going to be plugging 7 pi over 2 into this expression. But in terms of what I'm going to do, I'm doing the same thing, okay? So I'm still going to be multiplying by 1/3. So the answer here is going to be 7 pi over 6, and that will be my second solution. Okay, and now I'm going to move to my third answer, which would be 11 pi over 2. I'm going to put that in here. I'm going to do the multiplication, so that's going to give me 11 pi over 6 as my third answer. Now at some point I need to come back up here and I need to determine where the cutoff point is for my restriction. So I'm noticing that all of my answers, at least the last two, are over 6. And actually the first one was 2, we just reduced it out. Okay, so I'm going to take this 2 pi and I'm going to write it over 6 so that I can see what that's equal to. So I know that 12 over 6 is equal to 2 pi. So I don't want any answer that's bigger than 12 pi over 6. And when I look at my answers here, I can see, hey, I'm already at 11 pi over 6. So that's going to be the end. The next one is going to definitely be bigger than 12 and would get eliminated anyway. All right, so I've got these 3 solutions for my final answers. All right, so let's try one more just to give you a little bit more practice with it. All right, so this one says that we have secant 3 pi over 2 is equal to -2. All right, so again, first thing I want to do is I want to take out the 3 pi over 2, just make it a theta, or 3 theta over 2, just make it a theta, and look for some solutions. All right, so I have to figure out where secant is equal to -2. All right, so I know from a memorized value that secant pi over 3 is equal to +2. All right, so I also know on my charts for positives and negatives that the secant is the same as the cosine. So it is going to be positive here, and negative in the other 2 quadrants. All right, so here is pi over 3. And because it's a negative, I need to move it into the second quadrant and also the third. All right, so when I flip this line over into the second quadrant, we are going to be here. So that's going to be 2 pi over 3 for one answer. And then when I flip that line down into the third quadrant, it's going to fall here at 4 pi over 3. Okay, so that gives me starting places for both lines of answers. Now, remember the next step is to do the rotations. So we'll take the 2 pi over 3 and we'll add a 2 pi to it. That adds a complete rotation to it. So remember that we need a common denominator. So that denominator is going to need to be a 3. So what over 3 is the same thing as this 2? I would need a 6. So my next one is 8 pi over 3. And then remember, recognize that pattern. So how do you get from 2 to 8? From this 2 to this 8, you added 6. So we're going to do it again. So 8 plus 6 is 14. Same thing on the bottom line. 4 plus 6 is 10. 10 plus 6 is 16. Add 6 each time. Do it 3 times, realizing that you may need to come back in and do it some more, but 3 is normally enough. Okay, so that gets the first part done. All right, second part is to come back to the original problem. So now we're going to look at secant 3 theta over 2 and look at how that can equal negative 2. All right, so this is where we say to ourselves, I need this part to equal the first answer in my list. So let's do that. So 3 theta over 2 equals 2 pi over 3. Now, what do I need to multiply by to get theta by itself? So I would need to multiply by the reciprocal of 3/2. So I'm going to multiply both sides by 2/3. And so all of this over here will cancel, leaving me just the theta. And my first answer is going to be 4 pi over 9. Okay, so wherever I'm writing the answers to my problem, that's the first one in the list, 4 pi over 9. Now, the easiest thing to do is to recognize that the thing that you multiplied by to get 4 pi over 9, you multiplied by 2/3. So you could now come up here to the list and you could multiply each one of these times 2/3. So 8 pi over 3 times 2/3 would be 16 pi over 9. That would be the next answer. The next one is going to be 28 pi over 9. I'm going to do the same thing on the bottom. Multiply by 2/3. All right, so the first one is 8 pi over 9. Then we have 20 pi over 9. And then I have 32 pi over 9. All right, come back up to the top and let's determine what the cutoff point is for 2 pi. Note that all of your answers are over 9. So what over 9 is 2? That would be 18. So I don't want any answer that is bigger than 18 pi over 9, which means 28 is too big. 20 is too big. And 32 is too big. So the answers that we have for this problem, we have 4 pi over 9, we have 16 pi over 9, and we have 8 pi over 9.